Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Tom Singer and Craig Brown.
This is the Digital Enterprise Society podcast. Thank you so much for coming along on the journey of this show that we designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Tom Singer, and I have the honor to co-host this show every single week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. And every few weeks, we invite Mark Pendergast, who is the trustee for content at the Digital Enterprise Society and a person who has decades of experience in PLM. We invite him to the show, and Mark and Craig battle it out in what we call a digital battle. And today, that's exactly what we've got for you. So get ready, because today we're going to talk about how many engineering design tools do we need? Do we need fewer or more? So, Craig, what do you think?
Fewer. I'll explain in a little bit.
All right. And Mark, I assume you're going to say more.
I'm going to say more. I think really there's room to expand what we're doing, and that a lot of innovation is driven by new tools many times.
All right. So let's start off with my first question. Why do engineers need so many tools?
Well, there's a story. Right. And the problem is engineers are a creative bunch. Right. And a lot of them learn techniques from their professors that bias some tools. You know, one of the most famous tools that is used by almost everybody at some point is Simulink. Right. From MathWorks. And it's famous because it was available on campus, meaning it was really easy to get for free. Right. And so people use what they're used to, right? It's just like your tools in your garage at home that you fiddle around with your mower or your car, and you go get the tools you need. You go to the hardware store and you get them. So people are used to having their own tools. They have possession, they have ownership, right? And so that's why they have so many. And the real question is, well, do you need that many? Well, that's a really good question. I see the following complication. When we say tools, we're really mixing up three areas of digitization. One is the tool that helps you author, which is what most people think when we say this phrase. But then there's a database behind it that manages things and keeps files and so on. There should be few of them, by the way. And then there's libraries of knowledge, models, if you will, that get shared and get sold and maybe get evolve. You will have as many libraries as the richness of your product. And so saying a small list of tools and you mean all three is a little misguided. There's authoring tools, there's databases, and there's libraries. And I think the answer to how many of those do you need changes because they're very different things. They are all computer-based, and so that's why some manager might declare them tools. So we got to manage it well, but there should be fewer, especially of databases.
Mark?
Okay. Well, I think engineering and products have become very specialized, and we're pushing the frontiers of the possible in many, many cases as we're engineering new things. And many times there's some little startup or somebody that's got the tool that just casts the right light that you can see the path forward. And many times when a company says, I'm locking this down, these are the only tools you're going to have, they force fit engineers into a tool that doesn't necessarily have a great representation of the problem he's trying to solve. And they're very reluctant to expand that tool set. So I think there's kind of the concept of core tools, the ones we use all the time, and tools that are there to do certain kinds of analysis or certain kind of modeling that you can't do any other way. And there's always this fringe on the outside where I think you need to differentiate how you manage the two. So I think I'll split it a different way than Craig did and talk about core tools, the ones that are delivering the mail, and tools that help you conceptually figure out what's going on in your design space so that you can then move back into the core tools, confident that it's going to work when you're done. And I think this is really the key to it is, and even in, Craig said very, very few database tools, but anymore, what I'm seeing is there's so much specialization, especially as you start into process automation. Like I would have early in my career never believed I needed a process and data manager for simulation tools. Yet we bought one because it automated a lot of the routine work and really made our guys more productive. Now, we shipped the results up to the big PLM for long-term storage, but that database that was completely tailored towards how you do simulation really was a good investment for us because it really allowed us to do more things. So I think that's it, is you need to be able to look and see what makes sense, but you need that fringe of innovation, not just in your product, but that innovation in your tools as well, so that they might come up with the next core tool by looking at it. So I think that's where we are. And I agree with Craig. There's silly reasons like, I had that on my last job, or I had that in college. And, you got to be kind of suspect of those because there's a million tools that people use in college because all the vendors know you give them away free there and they'll demand them in their job. So that's where I am.
So you kind of, go ahead, Craig.
Well, I like what Mark said about workflow automation. That's actually a fourth area that's emerging. And a lot of people think robot aids are a bad thing because it takes away your job. Hey, if it takes away the monotonous work, the work where you don't pay attention to detail because you're just bored out of your mind, I think that's a good thing. And a lot of workflow tools do that. It's amazing. We seem to have a workflow tool per authoring tool, per physical domain tool, which is, again, nonsense. Workflow tools are like database tools. There ought to be a few of them that can span the organization. That way you can start to orchestrate larger processes, what Mark pointed out. So, for those of you listening, think about what kind of tool it is, and then ask yourself, can my special purpose tool for the physics or the problem domain I'm trying to solve be married into my database and workflow tools? And by the way, don't forget the libraries. And they're not really tools, but that's where the essential knowledge is, right? Being able to use a library of how a widget works is much more powerful than trying to model it from scratch, right?
Well, and you both kind of hit on my next question a little bit already, but let's go deeper on this. So should these design tools, should they be limited or should they be uncontrolled? If there's something out there and the engineer needs and wants it, should his hands be tied or should he be let to go get the tool?
The trouble with computer-based tools is the cyber threat. And so, and I've changed my view on this over the decades, but it's so pervasive now, it's a little scary to go uncontrolled. You just don't know where it came from, and you just don't know what risk it's bringing to the company. So one form of limitation is that you can run this candidate tool, whether it's open source software or whether you buy it from some company, and make sure that it won't bring other threats to your company because it happens to be connected to a network. The limited side, I would take, when I was a PLM leader, I would take people through benchmarking exercises. Okay, you like your tool. Here's the corporate common tool, say for mechanical design. Let's do a fly-off, a month, a week, 3 months if it's a really big thing, and let's compare them. But if they're close, you're going to take the corporate tool. There has to be some strong, compelling reason why I'm going to leave you have this extra tool. And this ignores the licensing side of it, because that's another reason this gets expensive is there's just too much to manage, right? You got a different supplier, you got a different contract, all this other stuff. So I'm in favor of limited, especially in certain areas, like I already mentioned, but be fair to everybody. If they got their own special tool, you owe it to them to give them an opportunity to show why it's better. And if they can show it's better, well, then you might move to that. Maybe it is better, right? Maybe it's time to switch. I think that's the way you encourage it. They should be managed. I know sometimes we have a negative view of that, but managed means you know what it costs, you know it won't bring threats, cyber threats, and you know that it's the best in class. And we're engineering companies. We want the best in class tools, whatever tools we choose. So sort of limited, but limited with fairness. It's not the wild, wild west where you can bring your own, home-brewed tool from somebody you found on the dark web. I mean, this is the whole problem with the way we share things these days is if you don't know the legacy of something, you probably shouldn't be using it. Sorry.
Mark, your thoughts?
Well, I think certainly there's a practical limit. I mean, you can't have an infinite number of tools. I mean, your budgets and your support capacity is going to limit it to some extent. But also I've seen abuses on the limited side. I remember, and Craig remembers back in the day when I was asked to lay out circuit boards in a mechanical design tool because it was the standard core tool for building cars and, various other things like that. In fact, Craig was involved in that.
Yeah, Mark, that was a manager speaking and clearly not an engineer because it's fundamentally different. Even digital circuits from analog circuits are fundamentally different, right? It's not too surprising there'd be separate tools for those, right? Yep. You might want to encourage your tool vendor to do both domains, analog and digital, but there's one or two that can do it now, but that wasn't a forte at the beginning, right? So this gets back to the point about physics, right? You might need a separate tool for different physics, right? Just whether you're doing thermodynamics or fluid flow or airflow or rattling at different frequencies. Yep. It's the way computers work, everybody. They all excel at a particular narrow niche of the domain. Yeah. And it's not surprising if you get out of that domain, you're going to have to need another one, a different one.
Yeah. Well, the other thing is a lot of tools these days don't have different physics. They have different application domains. Because I used to argue that we need a special thermal tool for circuit boards because they behave very differently than just solid bodies. Yeah. And lo and behold, we needed one. Even though it was thermal, even though I was doing the exact same calculations, it allowed me to set up the problem so much simpler. Because it just said, I'm assuming you're a circuit board, so I'm going to set 5,000 defaults for you. Yeah. And now you just need to tweak these couple and you'll get an answer out right away. Well, I got the argument back, this is just thermal. You should model it. Well, I don't have time to set those 5,000 variables to meet how my circuit board works. I just want to go use this one over here that assumes it's a circuit board, pulls in the circuit board model and already knows what everything on it is. So I think there's a lot of cases that get out on that fringe, and we just keep going further and further out on the fringe. I remember when we brought in ball grid arrays, and that was a big deal. And we needed tools to study how those sat on the circuit board and how they soldered and all these things. A lot of different tools for different situations. Lighting. I mean, just the trim appearance lighting gang. They need a million tools because they're trying to look at how does this look in reality rather than building a car to figure it out. So
it's a lot faster, right, to do that. And but yeah, how photorealistic it is really matters. Yes. I remember the ball grid array tools. Turns out they're not different than spot welding. But when you talk about the currents involved and the heat involved, it's really different, right? But spot welding a fender is really similar to a ball grid array, the dynamics and how it fails if you do it incorrectly, right? So. Mark, you're raising up a good point that maybe we can dive in for just a second. In simulation, the notion of the starting conditions, right, the load cases, if you will, that's part of what's in this library I talked about, right? The way you go about investigating how a circuit overheats is different than the way you investigate how an internal combustion engine overheats. They're both thermodynamics. But the fundamental thing causing the heating is different, right? Whether it's friction or resistance of a different sort in a capacitor or a resistor. I mean, a resistor resists things, but it generates heat as a result, right? So the point is managing the initial conditions and even the results you get from running a simulation. This is part of why, as well as workflow, the simulation data management people really picked up the ball, and it's different than just PDM and PLM. It's managing more than the design. It's managing the environment that the design works in. It's managing more of its behavior, right? And I think that's part of what people lose track of, these managers that say, well, why do we need all these tools? I can rest assured that design tools, though they're starting to change, design tools don't understand noise and vibe. The vibration of a hunk of metal and what it does to a design, where it will actually fatigue if you shake it and rattle it a lot, right? That's why we still do physical durability tests. So I think this is really important. And we don't talk enough about this. The management of the load cases, the management of the workflow, even the management of the analysis you do from the simulation results, that's a whole set of tools that largely is now called, simulation process data management. And people see that and they're like, well, Craig, you said give me less databases. You just argued for another one. Well, yeah, that's right. That's why I said fewer and not few, right? That you got to look at it really carefully and understand it. But you don't need two of them. One will do, right? And one simulation process data management tool will do. You just got to be able to plug in different solvers based upon the physics you're trying to deal with. And buy the libraries, buy the load case libraries from, there's all kinds of people selling them, from individual OEMs to the individual tool vendors that build the codes, the simulation codes. They all have lots of libraries. In fact, if you're really good as a company, you'll have your own libraries, which are part of your secret sauce. It's how your systems work.
So guys, are we ever going to see a slowdown in the amount of engineering design tool innovation and new introductions? Because it seems like there's constantly new things coming out, just boom, 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 boom. Is that going to slow down, or is there always going to be this like new tool, new tool, new tool?
In the current environment, it's always going to be new tools. They got very smart people that are looking at these problems that have either left industry or left other companies and said, you guys are crazy. I know how to solve this, and I'm going to come up with this new tool. And it is driving amazing products that we couldn't even dream of doing, because these guys got us a tool that can do XYZ analysis that we never even thought we could do. And even if the big boys keep buying up all these startups, there's still more startups. I mean, there's just no end to the complexities of engineering design when you're pushing it harder and harder and harder to get more out of less. And I think it'll actually accelerate before it slows down. I think we're still in a very immature market. I mean, we're still just grasping at some of the cool things you can do. And every time we think we got it covered, then you throw in AI or big data or something new as a way of approaching a problem that we've been trying to solve for 100 years and bring new flavor to it, where all of a sudden things that were impossible to solve are now solvable. So I think there's a lot of inefficiency in engineering, and a lot of that could be fixed by better tools. And again, people want to try them out and see if they'll work. And I agree, you got a limited budget, so somehow you got to keep your eye on it. You don't want to bring in viruses and whatever, but you need kind of like a proof of concept lab. I think Craig kind of touched on that. You just need to give these guys a chance to bring it in and try it and show you what it's going to do for them. And I think that's really it. But the key is managing the transition from the current core tool set to the next core tool set. And a lot of companies leave that till you're in the crisis stage. And so I think you need to keep up with the trends. You need to bring these things in and try them every now and again. Let the engineers see them, and keep the stable reasonably sized, but don't shut everybody down and say, well, you got to design in the mechanical tool because we're all CAD heads and that's the only tool we know works. So I think that's just it. We really need to foster innovation in a controlled way, but not stifle it and say you got to work in the core tool set.
Well, I agree with Mark, but I want to add one more thing. Because of the world dynamics going on and because innovation is accelerating, not slowing down, material science is changing, meaning we're discovering new materials to put into our products. Drones are made of plastic, right? And the way the winglets on drones, if you watch them move as they take the forces of the wind, it's amazing how they twist, right? Well, that couldn't have been done without simulation tools, right? If you change the type of plastic, or you go to carbon fiber, or you go back to a piece of aluminum because it's inexpensive, it's amazing what you want to do differently. It's just not a blade in the wind anymore. It's actually a different shape. And so energy efficiency, the decarbonization of our world, trying to move to things that don't cause worse problems with greenhouse gases and all of that, it will keep driving innovation. And it's the drive of innovation that requires new tools to help manage it. The last one, which we've touched on in a couple podcasts, is all about a different way of manufacturing. No longer do we take a hunk of metal and melt it and put it into a sheet and bend it and then weld it together. Instead, we're going to print it layer upon layer and then do a little bit of machining and we're done. There's all kinds of shapes we can create now that we can never create before. And we build them through using what's called additive manufacturing. Well, every time there's a new manufacturing technique or a new technology based on material science, there will be all kinds of new tools. So if you think you're going to manage your company with a handful of tools, that's like saying, I got a hammer and a screwdriver and I never need a wrench, which of course isn't the case. So anyways, it'll keep changing. And I think I want to stress the point we've been discussing. You have to benchmark, not every year, maybe every 5 years, every 7 years, and then be fair. If you find a better one, move to it and move away from the other one. And that'll be hard. People hate change, right? But that's what we should do. So keep your eye on it and keep moving. And the innovators will pick it up. They always do.
All right. So in the world of all of these engineering design tools, is there anything we haven't covered? Anything you'd like to touch on before we wrap up today's battle?
Well, I think I'd like to go to one of Craig and I's favorite analogies is the tool set is kind of like a garden. You're going to kind of let it grow out and get a little wild, but then you get to prune it back a little bit and get it closer to the core, and then you're going to let it grow out again. And I think it's this process of renewal that's really important when you're looking at your tool set, and not so much what the tools are in the set or how big the set is, but the fact that you're constantly kind of exploring around the edges and finding those things that are new and innovative and going to move you forward. And then when you say, okay, enough's enough, let's prune it back and get it back to a more manageable set. And then you let it grow out again. I think that's a process I've used in my career. And it seems to work because it's controlled, yet it's still got some latitude to try new things. And it's kind of organic, like a garden.
Greg, last word?
What Mark said was pretty good. I think I would just remind people that when somebody says use a tool and it's not from your discipline, so a mechanical tool for electrical engineering or a requirements management tool for software that came from mechanical, you at least need to do the benchmarking, because it turns out these tools get fine-tuned for the discipline that fostered them. And the disciplines, of course, need to work more together, and we've talked about that in other days. But the more they're discipline specific, so a particular kind of engineering, whether it's the physics or it's the training you got in school, the more you'll need probably a specialized tool. It's no different than a surgeon who has specialized tools in the operating room. It really is the same. And they too have more and more robots, the workflow automation. So that's going to happen. The whole goal of all tools is to free up your brain to work on the innovation and problem solving and get out of the record keeping. And a lot of times people get stuck on the engineering tools like, oh, well, I just want to draw this shape faster. Well, yeah, that's an efficiency thing. But at the end of the day, does it make you more innovative? You got to ask yourself, are you, a lot of people used to fail, break something, fix it, break it again, fix it, right? And they be in that cycle. Where modern engineering tools are going? You won't have fix and repair cycles with physical parts anymore. You might do some simulation what-if studies. They'll call it a trade study. But at the end of the day, when you finally commit, the thing's going to work. You'll have very few problems. And by the way, that's a measure that you got the right tool set, is you got less and less problems as you go to mass production. And so there are measures, we should measure it. Don't measure the number of tools, measure the reduction in late quality problems.
Well, Mark and Craig, thank you so much for being here for another digital battle on the Digital Enterprise Society podcast. And thank you for everybody who tuned in. You know what? We want you to come back every single week and tell all of your friends who work in and around PLM that they need to be listening to this podcast. Join us here every single week for more thoughts, ideas, and actionable information around product lifecycle management. The Digital Enterprise Society is the place for the exchange of ideas around digital manufacturing tools. Go check us out right now at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.